Hello everyone, this is Engineer A.C. Sahu, Faculty Expert Mechanical Engineering. Welcome to MKD Education. So today we will discuss about your engineering physics chapter 4, that is work and friction. This is the second class. So you have read lot of things about work and some concept about friction in previous class. Today we will discuss in deep about the friction. So let's start. So friends, to introduce this class, I can say the friction which is experienced between two objects in contact or two surfaces in contact can be expressed in terms of some laws, and those are called laws of friction. And you know, friction is having some advantages as well as some disadvantages. So it is important to know, as there are some disadvantages, how to reduce the friction. So it is also the prime concern. So the methods are adopted to reduce friction. We will discuss in this particular class. So if I will summarize this introduction, we will discuss about the laws of friction, advantages of the friction, disadvantages of the friction, and how to reduce the friction. So after end of this class, definitely you will be able to know about the laws of friction. As I have told, we will discuss methods to reduce the friction, and you will also enhance your ability to solve some simple numerical problems. As you know, friction got a chapter which you have read in mechanics also, chapter 3. So this physics class will help a lot whenever you will read your mechanics class, chapter 3, that is friction. So now come to the term angle of friction, right? So friends, friction already I have discussed in the last class. Friction means, you know, the force of opposition or the opposing force which comes into play whenever a surface or a body moves over another. And you know, the friction is encountered only because of the roughness of the surfaces, right? Now, the friction is having number of terms, out of which one of the important term I can say this angle of friction. So angle of friction कौन, right? So पिला माने friction होची इमिति गोटे जिंस जोटा डिपेंड करूची दीटा पैरामीटर ऊपर, जेमति मु कहली रफनेस है पैरामीटर. सो रफनेस ऊपर डिपेंड करूची फ्रिक्शन. फ्रिक्शन मींस एंगल ऑफ फ्रिक्शन है डिपेंड करूची, कोएफिशिएंट ऑफ फ्रिक्शन डिपेंड करूची. फ्रिक्शन होची गोटे फोर्स, फ्रिक्शन टा गोटे अपोजिंग फोर्स, से गोटे पैरामीटर नुह, दैट कैनॉट बी कांस्टेंट. फ्रिक्शन टा कांस्टेंट वैल्यू नुह, से डिपेंड करूची टू थिंग्स, गोटे नॉर्मल रिएक्शन ऊपर डिपेंड करिवो एंड द कोएफिशिएंट ऑफ फ्रिक्शन. फ्रेंड्स, जदि आमे कहिबा दीटा सरफेस जे कांटेक्ट रे अछंती ताको भीतर जेतिकी फ्रिक्शन आसीबो सेटा एक्चुअली कोएफिशिएंट ऑफ फ्रिक्शन को फिक्स हम कहि परिबा. फ्रिक्शनल फोर्स फ्रिक्शन फिक्स के ना कोएफिशिएंट ऑफ फ्रिक्शन बा एंगल ऑफ फ्रिक्शन. So first of all you should know what is angle of friction. So friends, suppose let's say this is a horizontal floor, right? Horizontal floor, and a body is placed over this floor like this. So what are the forces? Forces means, you know, weight of the body W, which is acting, you know, irrespective of the position, the weight is always acting downward, and the normal reaction which is acting upward. Normal reaction कौन ना, every surface reaction दोची, and normal reaction is because that reaction is perpendicular to the horizontal plane. So this is normal reaction. सबुठी जोठी भी सपोर्ट अछि रिएक्शन सेठी अछि. पर्टिकुलरली एठी हमर गोटिए डायरेक्शन रे तार रेस्ट्रिक्शन है जे मोशन तळु को जाई पारुनी. सो रिएक्शन ऑफ फ्लो. सो as it is perpendicular to the surface, it is called normal reaction. So rest condition रे जेतोला हमें फोर्स दोउनु बॉडी को डिस्प्लेस करिवा पई, these are the two forces. But if we apply some force to move the body, let us consider this is the applied force, let's say P is the applied force which is applied here to move the body towards the right. So as you know, these two surfaces, we are considering the two surfaces having roughness, so definitely some friction will be encountered. So whatever friction will come, what asibo? The friction always opposes the motion. Motion juade rahibo, friction just opposite. So जदि आमे applied force दोचे right को, obviously motion right को हवा पे चाहिबो body, but oppose करिबो किए ना ताको frictional force oppose करिबो. So this F is your frictional force, which is opposite to the direction of motion. So now these are the four forces: frictional force, applied force, normal reaction, and weight. So the resultant of these two forces, frictional force and normal reaction, आपको कितना angle कहते हैं ना 90 degree. Angle between frictional force and normal reaction, always remember 90 degree. So the resultant, this is the resultant. This is, I have noted it by symbol R. So what is R? R is the resultant of frictional force and normal reaction. So this R also a term is, you can say this R is called what? Total reaction. Total reaction. So remember this term. Sometimes exam re aase question re find the frictional force and also the total reaction. So total reaction means resultant of frictional force and normal reaction, right? So now this R, which is the total reaction, or you can say resultant, जेत्ती के angle करछि normal reaction सहित this angle, एटा को हमें theta, alpha, phi, whatever तमे एठी नेउछ theta जति theta निया. So this theta means angle made by the resultant of frictional force and normal reaction with normal reaction is called angle of friction. So ये theta टा हला हमर एठी angle of friction, right? So angle of friction is a term which is fixed value for a two pair of surfaces in contact. जदि ए दीटा surface को हमें change करि दबा, then theta रे value change होइछो. जे पर्यंत ए दीटा surface थिबो माने ए body आ ए floor से पर्यंत theta रे value change होबार प्रश्न उठुनी, right? दीटा surface माने हम कहउछे nature of the surface. So जदि एठी हम weight रे value change करिबा, normal reaction value change होबो, then frictional force will change होबो. Applied force रो direction change करो, frictional force change होबो. But this theta value never changes. Theta is called angle of friction and it is a fixed value for these two pair of surfaces in contact. Again हम कहउछि कोन angle of friction, short definition हम जे देखबा, it is the angle made by the resultant of frictional force and normal reaction with normal reaction. So this is your angle of friction. And friends, आमे जति एठु देखिबा another term आमे परे पढिबा सेटा, still then we टिके खाली hint दे देउछि. एटा गोटे right angle triangle form होछि, जोठी ए right angle रे एटा हला normal reaction Rn, एटा हला total reaction R. So frictional force को a side टा parallel, so this can be also, you can write F. So एठी tan theta केते होछि? Tan theta means angle of friction. So P by B perpendicular by base. यदि एटा angle ला, this will be base, this will be perpendicular. As you know, this is 90 degree. 90 degree रो दीटा साइड, गोटे base गोटे perpendicular, जो angle को जे रहिला basically ये हला base and the opposite side of the angle, you know, perpendicular. So P by B, that means F by Rn. Tan theta equal to F by Rn. And F by Rn, later on you will write, this will be mu, that is coefficient of friction. So this mu, which is called your coefficient of friction, is nothing but equal to F by Rn, which is also equal to tangent of the angle of friction. This thing you will read in laws of friction. Now come to the next term, angle of repose. So angle of repose is another important term you should know. Angle of friction janilo, angle of repose janiba. So what is angle of repose? Angle of repose, actually angle of repose and angle of friction, conceptual these two angles are different, but if we say the magnitude part, दोनों वैल्यू सेम होगा, ठीक है? If I consider, so you just consider this object, right? Let us consider this object. So here this is a horizontal plane and I have kept this duster over this plane, right? So here the forces, you know, downward is weight, upward is but normal action. Now the body can be kept in rest. Now what I will do, I will just increase the angle of inclination. Initially horizontal thila, mu टिके angle बढ़ेली so that this plane becomes inclined. You see the duster is still in its position. It is not moving. I am increasing the angle, still the duster is not moving. See? So now the duster moves. That means, just imagine when the duster moves. So the duster moves at whenever the inclined plane is making a particular angle. Suppose this is the horizontal plane and this is the angle phi, so that whenever a body is placed over this plane, the body just tends to slide. माने खसिबा स्टार्ट करूची, स्लिपिंग होबा स्टार्ट करूची. Whenever the body is placed over this plane and this plane is making phi angle with horizontal, सेतबेले body just start हैला because of its own weight. Remember आमे किछि फोर्स दोनु, the body is slipping downward because of its own weight. तार weight जेति कि अछि, suppose weight केते अछि ना w, which is acting vertically downward. So w रो गुटे component, w रो दुटा component आसीबो. You know, if this is phi, this angle is also phi, so that this will be w cos phi and this is w sin phi. So each w sin phi component responsible रहिबो body को downward motion दबा पाए. आमे एठी किछि force apply करनु body को downward push करनु. The body is slipping automatically because of this w sin phi. If the body is just slipping, जेतबेले start करूची slip होबा, so corresponding angle phi is of repose. Angle of repose. So remember, this angle of repose means the minimum angle made by an inclined plane with horizontal, such that a body, if it is placed over it, it will just slip down because of its own weight. So suppose phi ta amar 10 degree la, let us consider an example. 10 degree रो अधिक angle अछि, so body automatic slip करि जिवो. 10 degree रो कम अछि angle, body never slips. जेमति कि मु देखैली हेबे body slip करूनी. So angle of repose है minimum angle जो टू body slipping होबा start होछि, बा तमे reverse करि पर maximum angle जे पर्यंत body equilibrium रे रहउछि. ता पूर्व body सेठी के rest रहइबो. 0 रू angle ता केते ना 0 रू 10 degree पर्यंत body रो equilibrium maintain हेक रहइबो. 10 degree हेला माने body slip करिवो. And 10 degree beyond जेते angle हबो, 20 degree angle body slip करिवो, 30 degree angle body slip करिवो, but if it will be 5 degree angle, body will never slip. So the angle of repose is minimum angle with which or in which a body just slip downward because of its own weight. So if you analyze this angle of repose and the angle of friction as I have discussed, so these are different concept, but magnitudically both are same. माने आमे जदि दीटा प्लेन नउचे, सपोज एटा गोटे प्लेन नउचे, हॉरिजॉन्टल प्लेन गोटे, ता ऊपर अनदर बॉडी इज प्लेस्ड. सो आको भीतर जेति की फ्रिक्शन रहउची, एंगल ऑफ फ्रिक्शन जोटा का हम लिखुचे थीटा, एंगल ऑफ रिपोज फाई, दीटा तकर वैल्यू समान. माने सपोज फाई अछि 30 डिग्री, देन एंगल ऑफ फ्रिक्शन आल्सो विल बी 30 डिग्री. फाई अछि जदि 20 डिग्री, एंगल ऑफ फ्रिक्शन आल्सो 20 डिग्री. Conceptually different, but magnitudically both are same. If you consider the magnitude, angle of friction jaha asibo, angle of repose seya hi asibo. ए दिन सर ऑलरेडी मैथमेटिकल प्रूफ अछि, तमे करि परिबो प्रूफ मेकानिक्स रो अछि. सो एठी मु अब डिटेल जाउनी. नाउ कम टू द नेक्स्ट पार्ट. फ्रेंड्स, लिमिटिंग फ्रिक्शन ऑलरेडी मु फर्स्ट क्लास रे कहितली. व्हाट इज लिमिटिंग फ्रिक्शन? लिमिटिंग फ्रिक्शन इज द मैक्सिमम वैल्यू ऑफ द स्टैटिक फ्रिक्शन. स्टैटिक फ्रिक्शन रो मैक्सिमम वैल्यू है लिमिटिंग फ्रिक्शन. लिमिटिंग फ्रिक्शन गोटे पेयर ऑफ सरफेस रो मैक्सिमम वैल्यू, हाईएस्ट वैल्यू ताटू फ्रिक्शनल फोर्स केबे बॉडी हो ही नहीं. सो लिमिटिंग फ्रिक्शन गोटे वैल्यू जा ऊपर हमें बेस करके सब किछि डिजाइन करिबा सब किछि कैलकुलेशन करिबा सो दीज आर द लॉज फर्स्ट ऑफ ऑल फर्स्ट लॉ द फोर्स ऑफ फ्रिक्शन ऑलवेज एक्ट्स in a direction opposite to that in which the body tends to move if the force of friction would have been absent. So friends, if you consider static friction what? Now static friction means the force of friction, static friction means the force of friction comes whenever the body is in rest. सेही कंडीशन रे बॉडी रो मोशन नाही सो आमे कहि परबे जो डायरेक्शन रे बॉडी मूव करे को चाहू छी. Suppose this is the floor and this is the body. Suppose I am going to force apply kale P with certain angle, let's say phi, or let's say this angle is alpha, right? So the body tends to move towards right. I am talking about static friction, means the body is not in motion, but the body is trying to move towards right, and it is not moving. Kahi move karuni? Because of the friction. So friction asuchi, so the friction always, remember, friction always acts parallel to the plane. Parallel to the plane. Plane jemiti achi exactly parallel hisabare frictional force asibo. So this frictional force will oppose the motion and fully oppose karuchi. Suppose eta ame kaiba tar component kete p applied force p cos alpha. So this frictional force F completely balance karuchi p cos alpha ko jothme motion houni. So first law कहूची force of friction always acts opposite to the direction of motion. Direction of motion जदि body move करूची as you know it is static case, so the direction towards which the body tends to move. Body चाहूची right को जीवा पाए friction आसला left को. Never mind applied force को direction रची. Always mind body रो motion को आड़े होची. मुझे example दोची applied force जो आड़े friction भी साड़े. कौन देखो? Suppose it about inclined plane अछि it about body अछि right. So body is slipping downward and we are providing some force, applied force P, to keep the body in equilibrium and we are unable आमे equilibrium रखी पारुछे बा पारुना जहाँ भी हो body रो motion let's say downward, so apply करछे force P to keep the body in equilibrium. So एही केस रे फ्रिक्शन कोड आसबो, यू नो बॉडी स्लिप करछि डाउनवर्ड ऑब्वियसली फ्रिक्शन आसबो अपवर्ड काहे कि ना मोशन को सब बेले फ्रिक्शनल फोर्स अपोज करूछि अप्लाइड फोर्स को नो. सो एई केस रे अप्लाइड फोर्स P फ्रिक्शनल फोर्स F दीटा देखो सेम डायरेक्शन, दोनों सेम डायरेक्शन में क्योंकि मोशन नीचे हो रहा है, डाउनवर्ड मोशन हो रहा है, सो फ्रिक्शनल फोर्स अपवर्ड. बट प्रीवियस केस रे अप्लाइड फोर्स एंड फ्रिक्शनल फोर्स दोनों अपोजिट है. सो रिमेंबर frictional force always acts along the direction of motion or along the direction towards which the body tends to move. जोड़े कि हमारा first law है. Second law is magnitude of the force of friction is exactly equal to the force which tends to move the body. Remember, मु एबे just कहूतली static friction. Static friction रे हमारा body motion हो नहीं. सो ताले केते फ्रिक्शनल फोर्स आसीबो ना फ्रिक्शनल फोर्स सेति केसबो जेति कि सफिशिएंट टू कीप द बॉडी इन इक्विलिब्रियम. माने सपोज एटी p अछि, p रा कंपोनेंट हला हॉरिजॉन्टल डायरेक्शन रे p cos अल्फा. सो फ्रिक्शनल फोर्स एग्जैक्टली आसीबो F = p cos अल्फा. एग्जांपल जदी देबी सपोज ओडे बॉडी हमें एटी अप्लाई करूचे लेट्स से 10 किलोन्यूटन फोर्स अप्लाई करछे हॉरिजॉन्टल डायरेक्शन लेट्स से. So body still is not moving. Body जब move करूनी हम obviously will ensure that this is in static condition and the corresponding friction comes is your static friction. मोर कहया कथा ले ए static friction रो value केते हो ना exactly equal to the 10 kilonewton force. F = 10. So से कथा कहउची कि frictional force magnitude केते हो ना exactly equal to the applied force जोटा ही सफिशिएंट हबो टू कीप द बॉडी इन इक्विलिब्रियम. दैट 10 रु कमिबनी बा 10 रु अधिक हबनी. सो दिस इज योर सेकंड लॉ. नाउ these are your limiting friction concept. थर्ड कथा हम ऑलरेडी कहि सारिछि से दिन से हम कहउछे कि द मैग्नीट्यूड ऑफ लिमिटिंग फ्रिक्शन bears a constant ratio to the normal reaction. मु जस्ट टिके पूर्व से विषय डिस्कशन करथि. अगेन वी विल डिस्कस the magnitude of the limiting friction bears a constant ratio with normal reaction. So what is limiting friction? Already I have told you. Limiting friction means what a frictional force body maximum value जोटा reach करछि, that is your limiting friction. So if एठी body horizontal plane अछि, horizontal plane रे body is kept in rest, so the forces are weight of the body, upward रहला के normal action, आमे suppose force apply करछे केते ना p, so body towards right move करूछि बा करबा को चाहूछि, static condition move करूनी, body towards right move करबा को चाहूछि, so होउनी काहे कि because of this agent frictional force. So एक केस रे frictional force and your applied force दोनों opposite होगा, and let this is the resultant of frictional force normalization जोटा कहिथिले आगरे angle of friction कहला बेले, so this angle is no angle of friction. So now, so this is the total reaction or the resultant. So just I have discussed just before. So this side is parallel to this side, in magnitude also these two will be same, so that this can be, we can write F, frictional force F. So if you consider this right angle triangle, this right angle, let's say OAB. So in the OAB right angle triangle, this angle is 90 degrees, so this is frictional force 90 degree side रो दीटा साइड गोटे परपेंडिकुलर गोटे बेस एंगल एटा अछि माने एटा हला बेस एटा हला हमरो परपेंडिकुलर p. सो tan थीटा में लिखबा tan थीटा, थीटा कोन एंगल ऑफ फ्रिक्शन, tan थीटा इक्वल टू p by b, so f by rn. So bears a constant ratio, frictional force bears a constant ratio with normal action, always say जोटा हमें कहि छै, that means f by rn गोटे फिक्स्ड वैल्यू. So you know tan theta, f by rn hela mu, coefficient of friction. So mu is a constant value, but angle of friction is a constant value. F by rn, you know the ratio of frictional force and normal reaction is coefficient of friction. So ये coefficient of friction रहला गोटे constant value. Constant कहा पई? For a pair of surface in constant. So f by rn हला गोटे constant की नहीं, जोटा कि थर्ड लॉ, frictional force bears a constant ratio with normal reaction. That means frictional force by normal reaction equal to constant, and say constant टा किए ना coefficient of friction. So एठी गोटे रिलेशन आसी गला angle of friction और coefficient of friction भितर, एटा हमरो इंपोर्टेंट मन रखिबा mu equal to tan theta, coefficient of friction equal to tangent of the angle of friction, right? So next law is your force of friction is independent of the area of contact between the two surfaces. So this is also an important law. You know, this is somehow this is a contradictory law. काहे कि ना जदि एरिया बढ़ुची, then obviously roughness बढ़िबो, जेते एरिया ऑफ एक्सपोजर बढ़िबो, एरिया ऑफ कांटेक्ट बढ़िबो, obviously roughness बढ़िबो, so friction बढ़िबो. But आमे आ गोटे कथा चिंता करबा, जदि if the area is increasing, so जेतिकी roughness अछि सेतिकी जेतिकी increase ହେଲା area, that area is smooth. Area previously area was A, now the area is increased to 2A, but roughness is not increased. दीटा surface हमें consider करा जे contact अछि, आउ जेते area बढ़ुची roughness बढ़ुनी, then friction बढ़िबार नाही. So सेति पई एटा हमें कहि परबा कि it is not depending upon the area of contact, but reversely चिंता कले जदि एरिया बढ़िबो रफनेस भी बढ़िबो, बिकॉज़ सेम नेचर एरिया बढ़ुची ना, सो फ्रिक्शन बढ़िबा कथा. बट दैट्स व्हाई दिस इज ए कॉन्ट्राडिक्टरी लॉ. स्टिल यू रिमेंबर कि फोर्स ऑफ फ्रिक्शन नेवर डिपेंड्स अपॉन द एरिया ऑफ कांटेक्ट. इट डिपेंड्स ऑन व्हाट? इट डिपेंड्स ओनली ऑन द इरेगुलरिटीज, सरफेस इरेगुलरिटीज, दैट इज सरफेस रफनेस. सो दीटा सरफेस हम जदि एटा गोटे सरफेस अछि, this is another surface, the two surfaces are in contact, friction आसीबो, right? So एई surface जदि बढ़ुची ताले एरिया, सपोज एटा बढ़ी गेला, ये भी बढ़िला, सो बढ़ले कोन हला ना रफनेस भी बढ़िला, सो फ्रिक्शन अधिक होबा कथा, बट फ्रिक्शन अधिक होउनी. काहे कि ना जदि एटा सरफेस स्मूथ रहिला सो एरिया बढ़ले कोन हो इट इज स्मूथ सरफेस अछि सो फ्रिक्शन ओनली डिपेंड्स अपॉन दिस रफनेस पोर्शन दैट्स व्हाई फ्रिक्शन बढ़ेनी सो दिस इज ए कॉन्ट्रैक्टाइल लॉ नेक्स्ट इज फोर्स ऑफ फ्रिक्शन depends upon the roughness of the surface already कहि सालेनी so these are the laws important 8 ପାଇଁ from exam point of view already बार बार समान दिन से डिस्कशन होची so law लिखिबा को किछ असुविधा नहीं first law force of friction acts opposite to the direction of motion second force of friction is exactly equal to the limiting your applied force towards with which the body tends to move third is frictional force bears a constant ratio with normal action fourth is force of friction is independent of the area and fifth is force of friction depends upon the roughness of the surfaces now come to the next part so this is a question sample question for you so this is a numerical question very simple question now we will solve this question so again I am reading the question a body of weight 200 Newton is at rest on a rough horizontal floor. It is about to move by a force of 60 Newton inclined at 30 degree with the horizontal. Find the coefficient of friction. So see, question हिसाब रे body ओडे horizontal floor रे rest रे अछि, right? Suppose this is the horizontal floor. The body is in rest, and the weight of the body is 200 Newton, right? So 200 Newton means it is acting vertically downward. Friends, according to the question, a force which is applied at an angle of 30 degree with the horizontal. Suppose this is the force which is your 60 Newton applied at an angle of 30 degree with horizontal. Just move the object or the body. So this force can move the body towards right. We have to find what is the coefficient of friction. So these are the two forces, you know, and your obviously normal action will be acting vertically upward. So this is your normal action, and body right को move करुची, so friction will be towards left, right? So what are the given values? Given values एठी हैला कोन ना applied force P equal to 60 Newton, and your angle of inclination of the force with the horizontal alpha, let's say that is 30 degree, and weight of the object or the body is 200 Newton. We have to find the coefficient of friction. Coefficient of friction कौन? Already हम कही छी ना force of friction divided by normal action. Force of friction माने F by normal action Rn. So एठी हम कौन करिबा? So always remember whenever we will calculate or solve numeric problems, always we will take total forces acting along the direction of frictional force and along the direction of normal reaction. So if you analyze, you see a Rn direction रे 200 Newton already there, and F direction रे किसी force नहीं, but this 60 Newton force it is acting at an angle of 30 degree. So it will have two components. 60 रो दीटा कंपोनेंट आसीबो जो दीटा कंपोनेंट गोटी रहइबो डायरेक्शन ऑफ फ्रिक्शनल फोर्स रे आ गुडे कंपोनेंट रहइबो टुवर्ड्स Rn. So one component will be this, so this is 60 cos 30, and another component which will be acting vertically upward, this is 60 sin 30. So these are the forces F 60 cos 30, Rn 60 sin 30, 200. So I have 60 force nahi because it has been splitted to 60 cos 30 and 60 sin 30. So if we consider the equilibrium of the object, then total forces along the direction of frictional force 0, total forces along the direction of normal reaction 0. So हमें यदि x direction देखिबा, then two forces are F and 60 cos 30 which are equal and opposite. So हमें लिखि परिबा F equal to, from the figure, F equal to 60 cos 30. Cos 30 value कहते हैं √3/2. So this is 60 into √3/2. So this is 30√3. Then total forces along the direction of Rn also 0. We can write Rn plus कहते हैं 60 sin 30 equal to your 200. और implies Rn कहते हैं Rn है ना 200 minus 60 sin 30. Sin 30 is 1 by 2. So this will be 30. That means Rn is 170 Newton. Frictional force is 30 root 3 Newton. So what is coefficient of friction? Coefficient of friction mu equal to F by Rn. Direct formula, simple formula, mu equal to F by Rn. So what is F? हमें बाहर करचे पे 30 root 3 put करो. F is 30 root 3 divided by Rn 170. So if you calculate, the value will be 0.3. So mu, as you know, this is a ratio. This will not having any unit. So mu coefficient of friction equal to 0.3. So this type of questions you will face in your exam. Very simple question, right? So now come to the next part. So before coming to the key points, we should discuss some methods to reduce the friction. You know, ମୁଁ first class रे कहितली friction ର advantage कहितली, friction ର disadvantage कहितली, still then कहूची advantage कौन ना, because of friction only I can stand, you can stand, everybody can stand, everybody can walk, I can write something, you can hold your pen. So lot of advantages of friction are there, but at the same time disadvantages ରହିଛି, and the disadvantages are major disadvantages which are important threats for us. काहेकि ना फ्रिक्शन जो बहुत सारा पावर लॉस होची. सपोज हमर बाइक बा साइकिल तमे पेडलिंग करूछ, पेडलिंग देख ना तमे कोन करछ, साइकिल को मूव करूछ, बट मैक्सिमम अमाउंट ऑफ फ्रिक्शन जो पावर लॉस हो जाउची, राइट? सो सेथि समटाइम्स इट नीड टू बी रिड्यूस्ड, फ्रिक्शन को रिड्यूस करिबा दरकार समटाइम्स. So that's why we need to know what are the different methods to reduce the friction. Jodi friction or disadvantage achi, so definitely we should be able to reduce the friction. कौन method अछि friction को reduce करिया पई? So first method, first of all आमे कोन करिबा ना lubricant add करिबा. Lubricant रो एमिति गोटे property अछि जे plane को slip करेबो. So that you know, if you add some lubricant, definitely friction can be minimized. So that is the simple method. जोटी भी melting surface अच्छी बा relative motion आसुची, always we will add some lubricant. Lubricant कौन add करी परिबा? Lubricating oil add करी परिबा, grease add करी परिबा. So varieties of lubricants are there. हमें lubricant add करी की friction को reduce करी परिबा. Similarly, another method is there. तमे देखिथिबो बड़ बड़ सब मशीन रो तळे सब चक्क लागि थाए. काहे कि if you drag a heavy box, you may not be able to drag. So सेठी कोन होय ना फ्रिक्शन बहुत आसे. So ताको रिड्यूस करिबा पे हमें तळे व्हील लगेइथबा. Because of the wheel कोन होची ना सरफेस कांटेक्ट बदल रे जदि रोलर लागिची लाइन कांटेक्ट होची. सपोज एटा गोटे सिलिंडर, so ये रोलर जदि लागिची ग्राउंड सहित गोटे लाइन कांटेक्ट दोची, जदि व्हील लागिची देन ग्राउंड सहित से गोटे पॉइंट कांटेक्ट दोची. सो ऑलवेज रिमेंबर जदि एरिया कांटेक्ट नाही, फ्रिक्शन इज very less. दैट्स व्हाई हम कहितली रोलिंग फ्रिक्शन सेट पई लेस, बहुत लेस देन स्लाइडिंग फ्रिक्शन. सो दिस फ्रिक्शन नाउ कम्स, इंस्टेड ऑफ स्लाइडिंग दिस विल बी रोलिंग टाइप. व्हील लागि गले बा सिलिंड्रिकल रोलर लागि गले, दैट विल बी कन्वर्टेड टू रोलिंग टाइप. रोलिंग टाइप रे फ्रिक्शन आसुनी एथि पई ना सरफेस नाही, केवल गोटे लाइन अछि कांटेक्ट रे बा गोटे पॉइंट अछि कांटेक्ट रे. सो वी कैन प्रोवाइड द व्हील टू द हेवी मशीन्स. अनदर मेथड इज दैट कि हमें बॉडी को स्ट्रीमलाइन शेप करबा. स्ट्रीमलाइन शेप कोन तमे देखिथिबो ऑल द व्हीकल्स आगोटा टिके नारो हो जाइथिबो, बा बोट शिप तमे देखिथिबो बोट रो शेप केमिति थिबो, स्ट्रीमलाइन शेप, कन्वर्जिंग शेप. स्ट्रीमलाइन शेप हेले कोन हबो, फ्लूइड फ्रिक्शन कमिबो. से एटा सॉलिड फ्रिक्शन कथा न, एटा स्ट्रीमलाइन शेप फ्लूइड फ्रिक्शन कांसेप्ट. फ्लूइड फ्रिक्शन कोन ना, व्हेनेवर ए बॉडी, सॉलिड बॉडी इज मूविंग थ्रू ए फ्लूइड, जेति की रिएक्शन पाउची से अपोजिशन पाउची अगेंस्ट इट्स मोशन, दैट इज योर फ्लूइड फ्रिक्शन. सो स्ट्रीमलाइन शेप हेले फ्लूइड फ्रिक्शन can be greatly minimized. So these are the methods. Another method is that your suppose roughness achi, then by rubbing or by polishing you can reduce your roughness, so that also friction can be minimized. So these are the important things you should know. Now come to the your key points. What are the important points we should make note from this class, so that you will be finding simple to understand or simple to remember the total class. First, I can say, so these are the important points we should make note. First, the angle made by the resultant of frictional force and normal action with normal action is your angle of friction. जोटा कि ऑलरेडी मु बुझी सारछि एटा जदि हमर कोन फ्रिक्शनल फोर्स एटा नॉर्मल एक्शन होला आंकर रिजल्टेंट जोटा कि एमिति रहउछि. सो जेति के एंगल करछि ए रिजल्टेंट विथ नॉर्मल एक्शन, दिस एंगल इज योर angle of friction, and already explained hichi tangent of that angle of friction is your coefficient of friction. Third thing, friction is independent of the area of contact. Always remember this thing, area upar depend करू नाही. Fourth thing is rolling friction is less than sliding friction. काहे कि हम कहि सारछि rolling friction रे कोन होछि ना, instead of an area there is either a point contact or a line contact. जे cylindrical roller अछि line contact, spherical roller हेले point contact, जो पे friction greatly reduce होछि. So the questions कौन आसी पारे, possible questions. What is coefficient of friction? कौन coefficient friction? The ratio of limiting friction to the normal reaction is coefficient of friction. What do you mean by angle of friction? बार मु कहूछि angle of friction कौन? Angle made by resultant of frictional force and normal action with normal action. Next is, what is the relation between angle of friction and coefficient of friction? एबे जस्ट डिस्कशन है mu equal to tan theta. So coefficient of friction equal to tangent of the angle of friction. And what is angle of repose? Angle of repose मैं example दे के बुझे छी जानि पारथिबो. It is the angle or minimum angle made by an inclined plane with horizontal such that a body if placed over it just slips downward because of its own weight. So the last question is, what is angle of repose? Already I have told you, angle of repose means the minimum angle made by an inclined plane with horizontal such that if you place a body over that inclined plane, it will slide down because of its own weight. So that is your angle of repose. And angle of repose is numerically equal to angle of friction. दोनों का वैल्यू numerically same है, ठीक है? So this is all about your second class, and we have completed the chapter 4, that is your work and friction, right?